Now we can take that idea that we just did by sketching over a graph and instead try to approximate this definite integral by constructing this information. We'll sketch out a quick number line just to help us identify the intervals, but then calculate these values and come up with that approximation. So we're given the function x squared plus 2. We're given the interval from x equals 3 to x equals 15. So we can sketch out a quick number line and start with x equals 3 to 15. And we're told that we want to break this up into 4 rectangular regions. In order to do that, we would want to count by threes so that we would get 6, 9, 12, and then 15. So those are our 4 rectangular regions, meaning each region will have a width of 3 units, a little bit different than what we saw in the previous example where all of our rectangles were a width of 1. And now we can calculate what's called the left-hand Riemann sum, and then in part B, the right-hand Riemann sum. This is exactly what we did before. We calculated the area of the rectangular regions. We're just doing it without looking at the graph. In part A, we want a left-hand Riemann sum, which means we would start at the left endpoint of each interval and draw up until we hit our function, and that would give us the height of our rectangular region, meaning we need to evaluate the function at 3, 6, 9, and 12 to get the heights of those rectangular regions. And then those individual areas would be f of 3 times 3, that fixed width between each of our values, plus f of 6 times 3, plus f of 9 times 3, plus f of 12 times 3. Substituting those values into that function x squared plus 2 will give us 11 times 3, 38 times 3, 83 times 3, and 146 times 3. This will give us 33 plus 114 plus 249 plus 438 for a total approximate area of 834 square units. In part B, we want to use a right-hand Riemann sum, meaning when we're drawing those rectangular regions, we'd want to use the right endpoint of each interval to give us the height of the rectangle. So we would draw up from those x values till we hit the function and then square off that rectangle. This means we would calculate f of 6, the height of that first rectangular region, times 3, which is still that fixed width of each interval, plus f of 9 times 3, plus f of 12 times 3, plus f of 15 times 3, which would give us 114 plus 249 plus 438, plus f of 15 would be 227 times 3, or 681. And adding those up would give us an approximate area of 1,482 square units. Again, we come up with an over approximation or an under approximation when we draw those rectangular regions from different ends. And again, while we haven't looked at how to calculate that definite integral exactly, just for comparison to see how close we're getting with these approximations, the exact value for this definite integral would be 1,140. We'll work towards being able to calculate that precisely, but just to give us a range of how close we're getting with these approximations using these rectangular regions.